Hey students, we're going to learn how to solve one-step equations in one variable using the properties of equality. All right, so go ahead and do this review. There's some important stuff here to make sure you understand. Check back with your answers. All right, some important properties for you to know. For the first couple equations here, the addition and subtraction properties of equality. For any real numbers a, b, and c, if a is equal to b, then a plus c is equal to b plus c. What that's saying is you can add the same thing to both sides and they're still equal. So n minus 7 plus 7 equals 12 plus 7. And one thing you might note here, when you add negatives, minus 7 plus 7, that makes 0. So if you simplified that equation right there, you would have an answer for that. You would know n is equal to 19. So, and it also works for subtraction. A minus c is equal to b minus c. So if I subtracted 8 here and subtracted 8 here, I would get n minus 8 is 0, n plus 0 is n, and that's equal to 1. That gives me an answer that I know exactly what n is equal to. So that's the idea behind these problems here. This is what is the solution of 15 plus s equals 42. Now you can add anything you want to both sides or subtract, but what we want to do is isolate the variable. And to isolate the variable, I have to find a way to eliminate this 15. And one way I could eliminate that is by subtracting 15 from it. 15 minus 15 is 0, and 0 plus s is f. So that's what I'm going to do here. I'm going to do 15 plus s minus 15. And I'm going to, on the other side, I'm going to do 42 minus 15, because if you subtract 15 over here, you also have to subtract 15 over there to keep it equal. Now, 15 minus 15, that simplifies to just 0 plus s, which is just s, and 42 minus 15 is 27. I know no s is equal to 27. And if I check that, I would just do 15 plus 27, make sure that equals 42. Notice I substituted 27 for this s here to check it. So is that true? Since this is 42, that is true. So we're good. Yes, it's a solution. All right, go ahead, you try that. All right, you can also use addition to do that. Remember that when you add a number, an opposite to a number, you get 0. And that would help us isolate the variable in a problem like this. So we have negative 12 plus x equals 17. That's my original equation. And if I add 12 to negative 12, and last time I added horizontally, now I'm adding vertically. It doesn't really matter which way you do it. This would be the way I normally do it. Negative 12 plus 12 is 0. And so when I simplify that side, I get that 17 plus 12 is 19. But notice 0 plus x is just x. And so now my equation is a solution equation. It tells me that x is 19. And just to check that, I would substitute 19 for x in the original equation and just make sure that that equals 17. And if I add, oops, I added here, did wrong, didn't I? Made a mistake, sorry about that. 29, that's why checking it is a good idea. So negative 12 plus 29 is 17, now we're good. All right, and just think about what properties we use there. We added the same thing to both sides. That's the addition property of equality. We also use the identity property of addition because we said that x plus 0 is just equal to x, and we also simplified there. Go ahead, you try a couple problems here. And show your work here. Make sure you show the property of equality you're using. Check your answers there. All right, another couple of properties of equality we can use are multiplication and division properties of equality. And basically they're the same as the addition and subtraction. It's just that we're using the operations multiplication and division. And so if we multiply both sides of an equation by C, we will still have something equal. And here's an example. And the reason why we multiplied by 5 in this equation is because if I take x divided by 5 times 5, those 5's cancel out and they just equal 1. And 1 times x is x, so I can get the solution equation then. And you can also divide by the same thing. In this case, that'd be 6. Now, notice here 6 divided by 6 would be 1x. And 1 times x is just x. So again, I get the solution equation there. So let's try that here. I want to isolate the x, so I want to think, well, what can I do there to isolate the x? And I think what I want to do here is divide both sides by 2. I'm going to divide this by 2, and I'm going to divide 3/5 by 2. So I get 2 divided by 2 is 1x, using the identity property of equality. 3/5 divided by 2 is the same as 3/5 times the reciprocal, which is 1/2, and that's equal to 3/10. Then to check it, I would just do 2 times 3/10 and see if that equals 3/5. And that is 6/10, which, if I simplify it, it is equal to 3/5. All right, you try it. Fill in the reasons if you can think of them. You can check back if you don't know. Okay, another way we can solve these is by multiplying sometimes, and we know we want to multiply because we have a division problem here. And a lot of times you want to use the inverse operation to solve it. So since I'm dividing by 5, I'm going to multiply both sides by 5. And if we multiply 5 times x and then divide by 5, these 5's cancel and we get 1x. And then negative 12 times 5 is negative 60. And then we're just going to check that and make sure that negative 60 divided by 5 is equal to negative 12. And it is, so we're good. We're happy with that. What operation can you use to undo division? And we want to use multiplication to do that. All right, you try it. Okay, the last problem here, we're going to learn how to use, second to last problem, we're going to learn how to use reciprocals. Remember, when you multiply by a reciprocal, you get 1. And if we have 1 here instead of 5/2, that would isolate the variable because 1 times x is equal to just x, because it's the multiplication identity. So I'm going to start with this. And what I'm going to do is multiply by 2/5, because when you multiply a number by its reciprocal, it equals 1. Multiply both sides by 2/5. Now this is equal to 1 times x. And on this side, we get 30 over 5. And let's simplify that a little more. That's just x equals 6, and now it's the solution equation. So that's how you do that kind of problem. I'll let you try that. All right, and last problem, using one-step equation as a model. Here it says that Rob is driving at 40 miles per hour and Stacy is driving 3/2 as fast. How fast is Stacy driving? Well, I see an equal sign, an equation right here. Stacy is driving 3/2 as fast and I'm going to assume as fast as Rob, right? So I'm going to say Stacy equals 3/2 times R. And we can substitute 40 for R because it says Rob is driving 40 miles an hour. So Stacy is really equal to 3/2 times 40. And if I simplify that, I get 3 times 40 is 120 divided by 2 is 60. So Stacy is driving 3/2 times as fast as Rob. If he's going 40, she is going 60. All right, you try a problem like that. All right, that should do it. Go ahead and do the lesson check. Be ready to share that in class tomorrow, and I'll talk to you later.